Hello folks, welcome back, and today we are going to discuss reversing a linked list. Given a linked list, we would be given the head and the definition of list node is also given to us. So we want to reverse a linked list. Okay, let's see how we would approach this. The constraints are the number of nodes can be 0 to 5000, which means there can be null node also, and the value is fine. Like a linked list can be reversed with iteratively or recursively. Could you implement both? Okay, so first let's try the recursive method. List node head next and reverse dot next is equal to null. So we are trying to reverse the first element here, and after that, okay, so it looks like with this function we would not be able to do recursion. So let's first try the iterative approach. So while we have head, okay, till the time we have head, what we will do is okay, first of all we would have an if. Okay, so we don't want to lose a pointer at any point in time, and to do that, what should we do? And let's say return reverse. So we should never lose a track of our okay, so we should never lose a track of our head, and that should always be pointing to something. So the base condition is, let's say if head is not null, okay, and let's say if we have only one element in the list. So let's see if we should be able to, because in that case head dot next would throw an exception, right? So let's check that first. If head is null, we should return head, okay, and otherwise we would point reverse to head, and head would be head dot next in this case, okay, and reverse dot next is equal to null. So this can also go, but we want to keep track of this reverse, so we want to initialize it before entering into the while loop. So here okay, again we would do the same thing. We would reverse equal to head, but we would also want to the tail of the head, we would also like to keep a pointer on the same. Okay, let's try to understand this, right? So we are pointing our reverse linked list to this, so then we are saying that our head is now pointing to this element, and this would point to null, right? Next we would do is we would have a reference to this, so no need of keeping any reference here. We would so this would be our current reverse at this point. So point current reverse here, R we will point here, head we will point here, right, and its next we will point to this current. Makes sense? Okay, so that's why we would also need a current, which is fine for the first time, and we would keep a track of current here, right, or we can add it, because now we have a reverse. Okay, point that current here, and the current would be equal to reverse. Okay, now reverse we would point to head, and reverse dot next, or not reverse dot net, but yeah, reverse dot next we would point to current. Okay, is it clear now? Let's try to run it. While head not equal to null. Okay, so after reverse dot next we point to current, then we would also get rid of reverse. Okay, so reverse dot next equal to current, but that should be fine, right? If head is not null, then the reverse dot next should be pointing to current. Cannot find the symbol current. How can it not find the symbol current? Because current is already here. Oh, sorry, there is a typo. Okay, I think now it's working. So I hope you are able to understand what we are trying to do here. So let me explain once again so that it becomes clear to you. So what we are trying to do here is, let's exclude like this. If head is null, definitely we would respond with null. If we have only one element, then the same element would be returned, but how? We would have reverse, which is point to head, right? So reverse, so head is also here initially, right? Head is also here. Now what we would do is we would point head to head dot next, which is null, and reverse dot next would be null, right? Because the first element, we would like to point that to null, right? This should point to null. That is why we did exclusively the first these three lines from line number 14 to 16, so that we can point this to null. Now we would point head to head dot next, so we would point head to this. Okay, so we would point our head to this now. So after that we want to point this R to head, right? So but if we do that, we would miss our this element. So we would create a current and we would point to 1, and then we would point our R to this, right? And similarly we would do like this, but this next to this we don't want to point it to null, but we want to point to the current. Okay, and similarly like the current we would start again starting from this, because this becomes R now, so that's why it propagates like that. I hope you are able to understand within this iterative approach, and now let's try to implement the recursive approach. Okay, let's try to submit it. We are able to execute it in 1 millisecond, which is faster than 37. Let's try with the recursive approach now. Now to execute the recursive approach, we would do two things, right? We would create a new method, and this new method would give us a list node, and it would accept two parameters, actually 2 pointers we want to refer there. One is the new list that we are creating, which is reverse, and the current list. Okay, what should we do here? If we already have reached, so the edge case would be if we already have reached the end of the current list, then we would just return the reverse list, and that's it. Okay, and otherwise what we would do is we would have a current element like previously we had. Let's call it a temporary element, and that would become our current dot next. Okay, let's say let's make it current. Okay, and okay, let's point this to current, temporary, and this current would become current dot next. And this now this temporary element which we have is we want to point its next to the reverse of the linked list, and okay, we want to recursively call here, and to recursively call we want to call this method again, and let's call this method again, and we will again pass current comma reverse. Okay, but okay, so it's temporary, we do reverse, and reverse would now point to temporary. Okay, so I hope you are able to understand what I am trying to do here. So let's say we make divide this first element first, and after that what we trying to do is we send so first we have like these two elements. Maybe first even before that our revert linked list is null, and then we have this current one, reverse linked list null, and we have this current one, and then after that we have this current and this reverse linked list, and similarly like this becomes reverse, this becomes current, and it moves, it keeps propagating, and we are progressively like building from here to here to here. Okay, so let's try to call it from here. So one of the base cases, like if head is null, we would just return head. No, we don't want to do anything in this case, and we would start reverse with the null. Okay, so we would just return reverse, and we would pass on our head and a null. Okay, because we want to pass null here, and then it would recursively build it. Let's try to run it. Expected semicolon, line number 14. Oh, there should not be no space here. Oh, there is a typo. 23. Okay, semicolon should be outside. There's a typo here. Okay, and end of it we would just okay. So we are able to successfully run it. Let's try to submit it. Okay, so we are able to execute in 0 millisecond. Awesome. Thank you guys. See you in the next one.